Hello students. Today we are going to discuss wave equation. So I am here with one problem. So today we are going to solve that problem, which is under wave equation category, and that is our application of partial differential equation. So first we will read the problem. A string is tightly stretched and its ends are fastened at 2 points, x equal to 0 and x equal to L. Okay, so we have one string which is tightly stretched and both of its ends are fastened. Fastened means two ends are closed at 2 points, namely x equal to 0 and x equal to L. That is, the string two ends are joined at the points x equal to 0 and x equal to L. And then it is given the midpoint of this string is displaced transversely through a small distance b. Okay, so that string midpoint is displaced at a distance, small distance b, and the string is released from rest in that position. Find an expression for the transverse displacement of the string at any time during the subsequent motion. So if we released that string from rest in that position, then there will be some displacement of the string. So we are going to find the displacement expression in the subsequent motion. So what's our idea means, here that string displacement makes one wave equation. So we are going to consider wave equation format. So for that, first we will consider one graphical representation of this length of the string and displacement of the string at any point. So length of the string is mentioned in x axis and displacement is mentioned in y axis. Y-axis. So it is given length of the string is L. So I am considering this A and B denotes the two end points of the string. So total length of this one is L. So here our these 2 points are tightly fixed. So the movement is not happened in these 2 points. So at A your length is 0 and displacement is also 0. So we are considering coordinate of A will be 0, 0. Similarly at B, this is the next end. So the length of the string is L. Here also that string is fixed. So no movement is in this point also. So movement displacement is considered as 0. So coordinate of B is considered as L, 0. And the midpoint of this string AB is taken as C, and therefore this AC distance will be L by 2, and it is given this midpoint of our string is displaced at a distance B from this string. So that point is taken as D. So obviously your coordinate of D will be x coordinate, which is half length of the string, that is L by 2, and B is displacement. So this string midpoint is displaced at a distance B, therefore that displacement coordinate will be B. So we have D value as L by 2 comma B, that is coordinate of D. So the string is transferred into one curve format. So from this D point, that string is released and it makes some vibration. During that vibration some displacement will happen. So we are going to find equation for that displacement. So for that we should know the equation of the curve. So this string is in the format some straight line. So here we have two straight lines, one is AD and another one is DB. So we are going to find the equation of these two lines. So we know equation of a straight line joining 2 points. So that 2 points are suppose considered as x1 y1 and x2 y2. Then your equation of straight line will be x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1. So we know this is our equation. So now I am going to find equation of the straight line AD, which is joining the 2 points 0 0 and L by 2 comma B. So substituting in this equation, here x1 is 0, y1 is 0, x2 L by 2, y2 B. So we are substituting those values here and simplifying, we will get our y value equal to 2bx by L, where this x value, so x is vary from 0 to L by 2. So this is one of the equation. So your displacement may happen in this format. Similarly, the another one line DB is also we can find. So this DB is also a straight line which is joining 2 points L by 2 comma B and another point L comma 0. So applying the x1, y1, x2, y2 values in this formula properly, we will get our y value equal to minus 2bx by L plus 2b. So simplifying this, we get it as 2b by L into L minus x. So y, our displacement is calculated like this, where this x value is lying in this interval L by 2 to L. So we are considering these two. So we know that wave equation is dou squared y by dou t squared equal to a squared dou squared y by dou x squared. So this is our wave equation. We are going to solve this wave equation to find displacement of our given string at any given point x. So for that we have to assume the boundary conditions. So we know the standard boundary conditions are one is at the point at the initial point there is no displacement because the string is tightly fixed at this point, and similarly at the end also there is no displacement. So that is our first two boundary conditions. So we are considering y 0 comma t, that is at the origin, that is at first point A, the displacement y will be 0 at any time t. Okay, so this is our first boundary condition. Similarly at the next end, that is last end, that is at the point x equal to L and another end also displacement is 0, so which is considered as y y of L comma t equal to 0 at any time. Similarly, initial velocity will be 0 because at the time 0 the thing is in rest condition, so there is no velocity. So we know velocity is rate of change of displacement with respect to time, which is denoted by dou by dou t of y of x comma 0. That is at time t0 we are considering this one. So it is denoted by dou by dou t of y of x comma 0. That is our initial velocity. So we are assuming initial velocity is also 0, and this result is true for all x in 0 to L. So this is our third boundary condition. And then fourth boundary condition is the curve equation. So the displacement may form one curve which is considered as this straight line. So that one is initially that one displacement may be in this format. So time 0 the string is in this position only. Okay, so that one is considered as our last boundary condition, so which is taken as y of x comma 0. That is at starting point the string is in this format. So it is previously we discussed, this AD is 0 to L by 2 position, and DB is this L by 2 to L position. So we are considering those equations for this one, and this y of x comma t is obviously denotes the displacement of the string. So our displacement of the string will be in wave equation format, because if we apply any motion on that string, it will vibrate in wave nature. So we are considering wave equation. We know wave equation is dou squared y by dou t squared equal to a squared dou squared y by dou x squared. So for that we know our correct solution of the wave equation. So if we solve that wave equation, we have three types of solutions. Among that, two solutions are trivial solutions only. Only one solution is our correct solution. So we know that correct solution which satisfies our boundary condition is y of x comma t c1 cos px plus c2 sin px, c3 cos pat plus c4 sin pat. So this is our correct solution. So we are considering this is equation 1. So we are going to apply these boundary conditions in this correct solution and finding the displacement equation at any point at any time. So for that we need to put y of 0 comma t value. So that is our first boundary condition. So we are considering here y of 0 comma t. That is, in the place of x we are going to substitute 0. So if we put x 0 here, it becomes cos 0. We know cos 0 value will be 1. So this term becomes c1. And then if we put x 0 here, it is sin 0, which is 0. Therefore this total term vanish. So your first term becomes only c1, and in this second term no x term, so all the term will continue. So this is y of 0 comma t value. Now apply our condition 1, boundary condition. What is boundary condition 1? Says y of 0 comma t value will be 0. So substituting that value here, we get C1 C3 cos PAT plus C4 sin PAT value will be 0. So we know product of two terms is 0, then either first term equal to 0 or second term equal to 0. So we have C1 equal to 0 or this C3 PAT plus C4 sin PAT will be 0. So if this term C3 cos PAT plus this one will be 0, then your first equation, this total term will be 0 we consider, isn't it? So 0 into anything will be 0. That means we get our displacement will be 0. But this is initial we have the no displacement, so that solution is considered as a trivial solution. So we need a non-trivial solution only. So this term need not be 0. Therefore, the only possibility is C1 equal to 0. So our equation 1, so this is our equation 1. So in that only we are going to apply all our boundary conditions one by one. So first we applied the first boundary condition and we solved our C1 value must be 0. So substituting C1 0 here, so this term vanish. So now your equation 1 becomes y of x t equal to C2 sin px and these terms. So we are considering this is equation number 2. Now to apply the second boundary condition, we need y of L comma t. Then we can substitute that value be 0, isn't it? So I am going to put x value equal to L in our second equation. So initially we started with solution as equation 1. After modifying we left with equation 2. So now we are going to change equation 2. Okay, so y of L comma t, that is where and all x is present, we have to substitute L. So substituting x value equal to L, we get C2 sin PL and C3 cos PAT plus C4 is sin PAT. This is our y of L comma t. Now applying condition 2. So what is condition 2 says? It is y of L comma t value will be 0. So I am putting that value is 0 here. So we have C2 sin PL, C3 cos PAT plus C4 sin PAT equal to 0. So in that we have either C2 equal to 0 or sin PL equal to 0 or C3 cos PAT and this term equal to 0. As usual, if C2 is equal to 0, already we fixed C1 is 0. So if C2 is also 0, then if we substitute in equation 1, we get this total term will be 0. So again we get y of x comma t will be 0 into anything. So you get y of x comma t will be 0, which is a trivial solution. So our C2 equal to 0, your thing will become trivial solution. So that is C2 need not be 0. Similarly, as we discussed above, that is C3 cos PAT plus C4 sin PAT, that one also need not be 0 because that one also leads to trivial solution. So C2 is not equal to 0 and this term is also not equal to 0, which is confirmed, which are confirmed. So the final term will be sin PL equal to 0, but we know 0 can be replaced by sin n pi because sin n pi value is 0. So comparing this equation, we get these two terms, we get PL value is n pi. From that P equal to n pi by L. So now we know our P value is n pi by L. So substitute this P value in equation 2 because this is our current modified solution. So substitute p value equal to this n pi by L. So your equation 2 becomes like this, which is considered as equation 3. Next, to apply the third boundary condition, we need dou by dou t of y of x comma t. Afterwards, I have to substitute t value will be 0. So I am going to differentiate this equation 3 with respect to t. So which is dou by dou t of y of x comma t. So here this one has no t term, so which is considered as constant term. So we are keeping that one, and derivative of cos will be minus sine into n pi by L a, and sine derivative will be cos. So it is cos n pi by L a t into derivative of t will be n pi by L a. So now we have to put t value 0 here. So it is dou y by dou t of x comma 0. So putting t 0, it is cos 0. Cos 0 value is 1. So we have no, this one is sine. So sine 0 value will be 0. We have only this term, cos 0 is 1. So we have C4 term alone. So all are mentioned clearly. Now applying the boundary condition. So our boundary condition 3 is dou y by dou t of x comma 0 is changed to 0. So putting that value is 0 here, you get 0 equal to this one C2 sin pi L x C4 n pi by L. So that one, from that we can conclude C4 value will be 0 because C2 is not equal to 0, and n pi a by L, all these terms need not be 0 because all are some constant terms, and sin n pi by L x throughout that x we are considering, so that value also need not be 0. So the only possibility is that C4 equal to 0. The C2 is not equal to 0. We discussed previously, that same reason applied here also. Okay, so here we confirmed C4 will be 0. So your equation 3 is modified solution. Now change that equation 3 with the C4 is 0. So that equation 3 becomes C2 sin n pi. Where's that? Here we are putting that C4 is 0. So we have this term and this one alone. So here C2 and C3 both are constant, which is considered as some Cn, and remaining two terms are here. So this is one particular solution. So your most general solution is considered as y of x comma t summation n varies from 1 to infinity Cn sin n pi by L x cos n pi a t by L. So this is equation number 4. So this is our final modified solution. Now we have to apply boundary condition 4 in this equation. So boundary condition 4 is y of x comma 0. That is initial what is your curve format. So that is y of x comma 0. So to apply that boundary condition, we are considering y of where's that one? X. So in this we are putting t equal to 0. So it is cos t is 0, cos 0 1. So this term becomes 1. So we have Cn sin n pi by L x, which is considered as equation number 5. Now applying the fourth condition. So fourth condition will be our equation. This is splitted into two parts. One is x varies from 0 to L by 2. Another one is L by 2 to L. So we are Having this one, applying this condition 4 in this equation 5, we have summation this one. We rearrange this format. So right is changed into left. So left is changed into right. Y of x comma 0. But by boundary condition, this value is splitted into these two format. So it is in terms of x. So we can say this is function of x. So we know any polynomial can be expressed as summation of trigonometrical series using Fourier expansion. So in left side we have sine term alone, so we are considering Fourier sine series. We know Fourier sine series is sigma bn sine n pi by L x. So where that bn is calculated using this formula 2 by L integral 0 to L f of x sine n pi by L x dx. So this is our formula to calculate bn value. Now from equation 5 and 6, if we compare this 5 and 6, so both are same equation because y of x comma 0 is replaced like this. So here sine n pi by Lx, here also you have sine n pi by Lx. So if we equate, you will get this Cn value is nothing but bn. Okay, so to find a solution for our displacement, we need this Cn value. That Cn is nothing but bn. We are concluding like that. So our aim is to find bn only, to find Cn value, but I know how to find bn using this Fourier sine expansion formula, which is 2 by L integral 0 to L by 2, because our x is splitted into 2 interval. So it is 0 to L by 2 f of x, which is 2b by L x sine, this is in formula, sine n pi by L x dx plus integral L by 2 L, and this is our f of x value into sine n pi by L x dx. So here this one is integrated with respect to x. So the constant terms which is 2b by L in both integration. So we are taking that one outside. So we have 4b by L squared, and this one is integrated using integration by parts. So we are considering our equation as integral u dv format. We know by Bernoulli's formula, this one is uv minus u dash v1. So this u is considered as, for first term it is x, and dv is considered as sine n pi by L x dx. Similarly for the second term, u is considered as L minus x, and dv is the same thing only. So commonly we selected like this. So now we are going to differentiate u and integrate dv. Okay, to apply in this formula. So u dash will be 1, and integral dv will be v, and integral sine is minus cos n pi by L x by n pi by L. So u dash 1, u double dash will be 0. So we are having u dash, so we have to go up to v1. So again integrating this v, integrations are taken as suffixes and differentiations are taken as dashes. So again if we integrate v, we get v1, which is integral cos sine. So already one negative sign is there. So minus sine n pi by L x by n pi by L the whole squared. Similarly, if we consider the second term, u dash will be a derivative of x, which is minus 1, and this is our dv term. So all required terms are calculated. Now substitute in this formula. So it is 4b by L squared, u which is x, and v is minus cos, so we are taking like this, and then minus u dash 1 and v1 minus, so minus into minus will be plus, and this one is between the limit 0 to L by 2. Similarly for the another one, u is L minus x and v is minus cos, so it is minus L minus x cos of this term, and formula we have minus u dash 1 minus and v1 1 minus, so 3 minuses are there, so we have minus, and we substituted, and this one is between the limit L by 2 to L. So outside we have constant term 4b by L squared. So now we are going to substitute the limit. So yeah, first we have to put upper limit and then lower limit. So it is L by 2 cos n pi, this L and here this L, and if we put x value L by 2, that 2 L's are getting cancelled, so we have n pi by 2x by n pi by L. In the place of x we are putting the limit. So first term upper limit substitution is over. If we go for lower limit, it is 0 into anything will be 0, x 0, so it is 0 into anything will be 0, so the second lower limit will be 0, and then we are going to substitute here. So it is sin n pi by L, and x is L by 2, so L getting cancelled, so we have n pi by 2 x by n pi by L the whole squared, and then minus lower limit, so it is x 0, it becomes sin 0, sin 0 value will be 0. When coming to this term, it is L minus x is L, so L minus L will be 0, so upper limit if we substitute we get the whole term will be 0. If we go for lower limit, it is L minus L by 2, which is L by 2, already one minus is here, lower limit formula itself we have one minus, so minus into minus will be plus, so it is L by 2 cos n pi by L, and x is L by 2, L getting cancelled, so we have sin pi n pi by 2x by n pi L. Similarly, if we put for this term our upper limit, it is L and L getting cancelled, it is sin n pi which is 0, so the upper limit is 0. When coming to lower limit, already one minus is there, and lower limit one minus, so minus into minus will be plus, so it is L by 2 I am going to substitute for x, so L getting cancelled, you have sin n pi by 2 x divided by this one, so this is minus L by 2 so and so, and this is plus L by 2, so both the term getting cancelled, so and then these two terms are similar terms, so this is one time, this is one time, so we have 2 times this term. So if we write reciprocal of this one and we can cancel, we get our Bn value is like this, but we know Bn is nothing but Cn, so your Cn value will be this one. So our aim is to find the Cn to get a solution for displacement of the string at any point. So now our current modified solution is in fourth equation. There we are going to substitute our calculated Cn value. So if we substitute the Cn value, we get our displacement equation will be this one. So this is the solution of the string which is under the category of wave equation, which is one of the application of a partial differential equation. I hope all of you enjoyed this lesson. Thank you.